So here, if we're trying to rewrite this quadratic in the form of y equals a times x minus p all squared plus q, by the way, what is this form called? Vertex graphing. So let's start with standard form there. Y equals 3x squared minus 6x minus 5. What am I going to do to get it into that other form? Complete the square. Before I can complete the square, what's the first step? Factor that 3 out of there. So I'm going to factor the 3 out, so I get 3 bracket x squared minus 2x, and I don't worry about pulling it out from the negative 5, because it doesn't matter. Now what? Half of my linear term there, so half of negative 2 is negative 1. You can hardly see that. Negative 1 squared is 1. What do I do with that 1? I add 1 and I subtract 1 inside my brackets. Now, I want to make that into a perfect trinomial square, so I need to distribute this 3 into which term? That last one, that negative 1, right? So it's going to turn into y equals 3 bracket x squared minus 2x plus 1, and then minus 3 minus 5, right? So just getting that last term out of there. Now, this is factored down as what? X minus 1 all squared, and then minus 8. Awesome. So there you go. You've got this thing now in Vertex graphing form. So you should be able to do all the rest of these questions without too much trouble. So first off, A, what are the coordinates of my vertex? Positive 1, negative 8, right? And again, the reason it's positive 1 is this is x minus p, right? So it's actually a positive 1 there. What's the equation of my axis of symmetry? Good, x equals 1. It's just the x coordinate from my vertex, right? Because it flips right there. Now, concavity. Up. And how do you know? Yeah. My a value is 3. It's positive, so it's up. How do you find the y-intercept? Set x to 0. Now, where would I want to do that? Probably in standard form, because if you made x 0 there, what do you have left? Negative 5. So my y-intercept is, yeah, so y equals negative 5. Easy enough. How do you find the x-intercepts? Make y 0. So that's going to take a little more work. I'm going to use a different color here to make it obvious. If we made x 0 to get the y-intercept, here we make y 0, so you're going to go 0 equals 3 bracket x minus 1 all squared minus 8. And I chose to do the vertex graphing form because if I went with standard form, I'd just have to get it in this first, so I'd be redoubling my work. So let's do this. What am I going to do now? Add 8. So 8 equals 3 bracket x minus 1 squared, then divide by 3. So 8 over 3 equals x minus 1 all squared, and then, so when I introduce the square root, plus or minus, so I'll just keep going here. So you end up then with plus or minus root 8 over 3 equals x minus 1. Then what? Add 1. So 1 plus or minus root 8 over 3 equals x. And you said what, Logan? I'm breaking a rule. What's the problem? I can't have that fraction inside my root. So what am I going to do? Multiply by root 3 over root 3. Now, by the way, that root 8 I can simplify as well, but we'll get to that. If I just multiplied by root 3 over 3, I'd get root 24 all over 3, right? And that equals x. Now I'm going to keep going up here yet again. If I want to combine that to be one fraction, what do I have to do? Multiply this 1 by 3 over 3, right? So I'd get 3 plus or minus root 24 all over 3 equals x. Root 24 I can simplify. What does it become? Two root 6. Good. All over 3 equals x. Now, that's my x-intercepts right there, right? If you go 3 plus 2 root 6, that's one of them. If you go 3 minus 2 root 6, that's the other. Then, I should also be able to find the max or min. Do I have a maximum or a minimum here? I have a minimum, and the reason is because I'm going concave up. We could figure that out. It's just the vertex, y coordinate. And we're out of time.